Okay, welcome to the video today. Now, in this video, what we're going to do is I've taken some questions from a previous past paper and we're going to be answering these questions. Now, the thing that you should focus on the most in this case is how to answer these questions correctly, right? And how to go about finding the answer, right? Yeah, in some cases, maybe we'll need a calculator. However, I do not carry a calculator with me. So in those cases, you can finish off the question. However, I'll give you obviously the techniques that you could use to find the answer. So in the first type of question in grade 11, the paper one question, in question one, you usually run into solving for x in each of the following, right? So the first one is 1.1, and the first one is 1.1, and it basically says 1.1.1, and it basically says that x, when it multiplies to x plus 1, is equals to 0. Now, this type of question is something that I think you have seen quite a number of times by now, since you're in grade 11. But generally, the idea is that, remember, these two things are multiplying each other. We have x multiplying 2x plus 1, not just 2x, but 2x plus 1, the entire 2x plus 1, to give us 0. The only way that this could ever give us 0 is if either one is 0 or both is 0, right? So that's where or comes from, right? That's where we say, okay, then therefore x is equals to 0, or 2x plus 1 is equals to 0. And again, why is that? It's because it's either that x is 0 or 2x plus 1 is 0 or both of them are 0. And basically that's what or means, right? That's what or means when we basically say or. Okay. So in this case, we know that definitely x can be equals to 0. But now in that case, for 2x plus 1, we just need to solve for x. And in this case, x would be negative 1 over 2, right? And you know how we got there. Whatever you do on the left hand side, you must do on the right hand side. We take the negative 1, we put it onto the left hand side, it is negative 1. We take the positive 1, it becomes negative 1, sorry. And then we divide by 2 on both sides, and it gives us negative 1 over 2, right? Quite clear. Okay. Now the next question here, which is 1.1.2, says 5x squared plus 2x minus 6 is equals to 0. And then they actually kind of give us a very interesting hint. They say correct to 2 decimal places. Now, if they're going to say correct to 2 decimal places, they're basically giving us a very interesting clue that the roots or the solutions to x are basically what? Are basically could possibly be irrational numbers. It could possibly be numbers that have decimals, right? So in this case, it's just 5x squared, 5x squared plus 2x minus 6 is equals to 0, right? Now, when you look at this solution here, the problem is that obviously you can't actually find two factors that have whole numbers, right? And when I talk about factors, I'm talking about two brackets where it would be x, maybe 2x plus 1 and 3x minus 1, right? And they're all basically factors, right? This is two factors, right? So the problem is that we can't actually find that, right? So since we can't actually find that, we could use what? We should probably use the quadratic formula. So if you use the quadratic formula, luckily the quadratic formula basically says that it is minus b plus minus, right? Plus minus y, because we are taking into account that the square root basically doesn't take into account the sign, but when we calculate it, we need to put plus minus, and then it is b squared minus 4ac minus 4ac, all divided by 2a, right? And then in that case, then the only thing we need to do is minus b. B in this case is 2, so it's minus 2 plus minus the square root of 2 to the power 2, right? Minus 4 times 5 times negative 6, right? And then we all divide by 2 of 5, and then we'd get our solution there. Okay, so from there, then you're supposed to get the first solution. The first solution would be the one for 2 minus 2 plus the square root, um, 2 squared minus 4 of 5 times negative 6, right? All over 2 times 5. And the second one, and the second one would be the minus 2 minus the square root of 2 to the power 2 minus 4 of 5 times negative 6, all divided by 2 times 5, right? And basically whatever you get there when you use your calculator would be the solutions in this case, right? Okay, so basically that's why basically they actually gave us this, told us that we need to correct it to 2 decimal places. And as I said, it's a very good clue because it actually tells us that the solutions themselves wouldn't be whole numbers. They would be irrational numbers, and because they could be irrational numbers, the only formula or the only way that we can know how to calculate quite clearly would be using the quadratic formula. Okay, and then we have 1.1.3, so 1.1.3, so 1.1.3, and it says 2x squared minus 2 is greater or equals to 3x, right? So it's 2x squared minus 2 is greater or equals to 2x. Now this is what we call an inequality, right? And basically a solution for an inequality is not one value. It is a set of values, right? It's basically a list of particular numbers that we could have, right? So we still treat it as an equation. We still treat it as a normal equation. But the only difference now is that at the end, we get an interval of solutions. So now, in this case, the only thing we have to do, we just rewrite it, okay, 2x squared, it's minus 3x, because we take 3x onto the other side, minus 2, that is supposed to be greater or equals to 0, right? Fine. That's quite clear. But now the issue is, you need to find what would be the critical values. Now, the critical values of an inequality is basically you solving for x, right? So you have a quadratic in this case, and how would we solve a quadratic? In this case, how we solve a quadratic is actually to try and find what would be the factors. But in this case, we have 2x squared minus 3x minus 2, right? So what can we do? We could either use the quadratic formula, which would give us the answer, right? Or we can try and factorize. Now, if we try and factorize in this case, let's see what would happen. So, on the side, let me choose just a different color. So on the side, if we have 2x squared, we know that when we usually solve a quadratic equation, we'd say there's x and then there's x. Definitely there's supposed to be a 2, right? That would multiply to give us 2x times x would give us 2x squared, right? And then we go to the last number, or the constant. Now the constant is minus 2. What are the two numbers that we multiply together to actually give us 2? There's only one option, which is 1 times 2, right? And 1 times 2 is 2. But now, the issue is that it's negative 2, meaning one of them has to be negative, one of them has to be positive. So what would we multiply together to give us 2, but then at the same time, when we add it together, it should give us minus 3. But in this case, because we have 2x and not just x times x, then we have to actually say, we actually take into account 2x there. So in this case, if we had placed 2 on this side, it would have been 2x times 2, which would have given us 4x, but then that would be minus 4x, and if we put 1 on this side and we say that's a positive, that would be positive x, that would give us minus 3x. Okay, did you understand that? So basically, if let me show you if I expand it. So basically, if I expand this would be 2x times x, 2x times minus x would be 1 times that and 1 times that, right? So it's 2x times x, which would give us 2x squared, right? 2x times that would be negative 4x, right? And then this would be positive x, and then that would be minus 2. But as you can see, minus 4 plus x would give us minus 3. So definitely that should be our factors. But remember, in this case, we're not trying to actually show the factors and all that. What we're trying to do is actually solve and find the critical values. So if you had to solve this, then you would have equated it to 0, right? And when you equated it to 0, then you would have said this is 2x plus 1 is equals to 0, or x minus 2 is equals to 0, right? And basically then your x is supposed to be either minus half or your x to be 2, right? But again, as I said, this is just helping us to find the critical values, and it's not actually part of the solution. What is part of the solution is your actual solutions at the end, being that the critical values, right? The critical values, right, would be x is equals to minus 1 over 2, or x is equals to 2, right? So that's what you'd state as your as part of your solution, right? And then from there, the only thing you need to do is use either a number line, right? So if you use a number line, which is I believe is the easiest one you could use, the number line, you'd say it's minus 2. So minus 2 is smaller than 2. So minus 2 would probably be here, right? And 2 would be there. Then the next step is obviously now to take into account the numbers that you'd find in between. So for instance, if we look at minus 2 to 2, we know that 0 is in between minus 2 to 2. So if we put 0 in here, right, we put 0 into the original equation. We want to see whether or not it would give us a value that would be either negative or positive, right? So in this case, then we would have said it's 2 of 0 squared minus 3 of 0 minus 2. But then this is 0 because 2 times 0 to the power 2 is just 0. Negative 3 times 0 is just 0. And then we get negative 2 as the final answer. So actually the final answer here is minus 2. But minus 2 is less than 0, right? And if it's less than 0, that means that in this case, in between negative half and 2, it's supposed to give us negative values, right? Okay, and then we check the next part of it, and we look at maybe the other side. So which side are we going to look at now? Let's try and look at anything that's greater than 2. So anything greater than 2, let's try out 3. So if we said it's 2 to the power 3, 3 times 2 times 3 to the power 2 minus 3 to the power times 3, sorry, minus 2. And in this case, then it is 3 to the power 2, that's 9 times 2, that's 18, right? Minus 9 minus 2. Definitely this would give us what exactly? It would give us 7, right? So it would give us 7, which 7 is greater than 0. Hence, that means that any number that is bigger than 2 would give us 7, a positive number, right? Would give us a positive number. And then you do the same thing again with minus 2. In this case, and anything that's smaller than minus half, right? Or minus 1 over 2, right? So anything smaller than minus 1 over 2, it will definitely give us a positive value, right? Now, how can I say with certainty that this is a positive value without doing the same thing that I had done with these ones? Is that, remember, this is a quadratic equation and you have studied functions in quadratic equations, and basically this is a quadratic equation that is looking up because, as you can see, the a is a positive value. So another way of that you could have done it is actually by looking at it and saying that, okay, if we had to draw in a quadratic equation of this quadratic here, it would have gone through like that and like that. And as you can see, the quadratic equation, if we imagine that this number line here is a Cartesian plane, then this 2 and negative 1 over 2 is actually the x-intercepts, and then these x-intercepts are basically in between them. The parabola would fall underneath the x-axis, meaning these are negative y values, and then above the x-axis, these are positive y values. Okay, right. So we've actually basically answered the question in a sense that we know now where it would be positive and where it would be negative. But remember, the question itself said what? It said it is greater or equals to 0, right? Greater or equals to 0. And when they talk about greater or equals to 0, it just basically means that it's positive numbers. So where is it greater or equals to 0? It's 2 to infinity and negative half to negative infinity, right? But because they said it's equals to, we also have to check in if negative 1 over 2 would actually give us 0, right? So let's see what would happen. So if we'd say it's 2 of negative 1 over 2 squared minus 3 of negative 1 over 2 minus 2, then in this case, this would be 1 over 4, right? 1 over 4 times 2, that's 1 over 2, minus, okay, positive 3 over 2 minus 2. But 1 over 2 and 3 over 2 would be 4 over 2, right? 4 over 2. But then 4 over 2 just means it's 2. So it's 2 minus 2, and so it's 0. So it does include the minus 2. So it's part of the solution, right? Minus 2 is included, right? And then when we check in with 2 as well, we do the same. We say, okay, it's 2 of 2 times square minus 3. It's 2 minus 2. And then you can see here, it would be 2 to the power 2. That's 4 times 2. That's 8. And then that's minus 3 times 2, which is 6, right? And 6, and this was 8, so it's 8 minus 6 minus 2, but then that would just give us 0 as well. So this is also included as well. 2 is also included as part of the solution set, or the interval set of the solution. So this is also included, and it goes that way. And this is also included, and it goes that way, right? So, and remember, the dots basically mean it's included, right? Not an open dot, but a closed dot, basically means that it's included. And therefore, then we can say we have x, which is an element in interval notation from negative infinity to negative 1 over 2, closed bracket to indicate that negative 1 over 2 is included into the solution set. The union of half of the closed set of 2 to positive infinity, right? And open bracket, because infinity is not really a number, it's a concept. It's a concept of being that there are numbers that are greater than any number that you could think of. Basically, if you think of 10,000, there's a number that's bigger than 10,000, and so on and so forth. Or you could have written it in set build notation, and in that case, then you could have also just written it and said we have x where it is less than or equals to negative 1 over 2, or when x is greater or equals to 2. And basically that could have been your solutions, right? So that could have been your solutions in the ways that you could have written it, right? So as you can see, this would be how your solutions should look. The other parts that we had done with the critical values, how to find the value, how to find the critical values is not important. It's about the critical values, and also at the same time, it's how you place out your number line, whether you use the parabola or you use just the normal way of doing the simpler way of doing number lines. Okay, and then the last one that we had here is 1.1.4. So here in 1.1.4, it's actually 1.1.4. So in 1.1.4, we basically have that it is the square root 2x plus 5 minus 3 square root 2x plus 5. Okay, so let's say it is the square root 2x plus 5 minus 3 of the square root 2x plus 5, right? That's supposed to be equals to, that's supposed to be equals to minus 2. Okay, so this is 6 marks. Now there's a number of ways that you could have done this. You could have even used the K method if you wanted to, but for the first attempt I will use the K method, and then the second attempt I'll use the more crude method, right? So in this case, for the K method, let's say let K be equals to the square root 2x plus 5. Such that this square root 2x plus 5 just becomes k minus 3 of k is equals to minus 2, right? That looks more simpler. And in this case, then, to solve this, since you have a fraction, you need to get rid of, obviously, the denominator. So how could we get rid of the denominator? We could have multiplied on both sides by k. So I multiplied by k on both sides. Here you get minus 2k. Here you get its k squared minus 3, right? Because this k would cancel out with that k, and then you have k minus 3 of minus 2k. And then from there, we can just, since we see that if we take minus 2k onto this side, then it's positive 2k minus 3 is equals to 0. And in that case, then, and remember, K method is just to make our calculation look more simpler and to not get confused, right? So then it's k squared plus 2k minus 3. And in this case, then from here, what we need to do, we can just say we have two factors, right? Because this is a quadratic, and when we solve a quadratic, we have two factors. So it's k and k. And you could have used an even your quadratic formula, but your quadratic formula would be equals to k, right? And then what would be the factors? So what are the two numbers that we multiply to get us 3? But then when we add, gives us 2. So then in this case, if I said it's positive 3 and minus 1, right? This would give us definitely that it's minus 3 as a constant and 2k, right? So from there, then you can say, okay, we have k that is supposed to be equals to 1, or k that is supposed to be equals to minus 3. But then, remember, we're using the k method. We've solved for k, but now the actual question was the square root 2x plus 5, and we're looking for x, right? So then, in the place of k, then we replace k with 2x minus 5, right? Which was plus 5, sorry, which was the original value of k, right? Or square root 2x plus 5 is equals to minus 3, right? And then from there, you just solve this. And since you have a square root, how do you get rid of the square root? You would square on both sides, right? 5 squared is equals to 1 squared. That's just 1. And this is 2x plus 5. And in this case, it would be 9, right? If I did the same thing where I just squared, right? And this would be 2x plus 5, and then that would give us 4 over 2x, and that's just 2. And in this case, then it's minus 4, so it's minus 4 divided by 2x, and then if we look at this, this would be minus 2. So we get two solutions. The first one says it's 2 and minus 2. However, the final answer in some cases, and in other cases it won't be both of them, right? And why is that? Just because when we square root, it ignores the positive and whether something is negative as well. Okay, so in that case, then what can we do? We take both of the solutions, and we check them. So let's take -2, for instance. So if we take -2 in this case, and we said it is 2 times -2, that will give us -4 plus 5, that's just 1. So that is actually the square root 1. So it's actually 1 minus, and we know that square root 2x plus 5, when x is -2, is just 1, right? So then that would be 1 minus 3, and that does give us -2. So definitely the first part of the solution, this one of minus x is equals to -2, is definitely correct. But what if we look at 2? So if we look at 2, then it's 2 times 2, which is 4, plus 5, that is 9. What is the square root of 9? It's 3, right? So then we know that for square root 2x plus 5, it is 3, so it's 3. And then we have minus 3 all over 3, right? Because this is all the value 3, so it's 3 over 3, which is just 1. So it's actually 3 minus 1, but 3 minus 1 is 2 and not positive, not negative 2, right? So if it's not -2, then it's quite clear that in this case, then this solution is not part of the solution set. So therefore, the final solution is that x is equals to -2, right? And that's the only solution that works for this particular calculation. But let me show you the other way you could have done it, which would look more complicated. However, it's still the same procedure in which you would have done the first one, right? When you replaced your 2x plus 5 with k, right? So then it's -2. So then in this case, then when we have to do this, same thing applies. Let's multiply by square root 2x plus 5 on both sides. So I'll multiply by square root plus 5 on both sides. So in this case, then what would it be? It would be the square root of 2x plus 5, right? All multiplying the square root 2x plus 5. That is subtracted by 3 over the square root 2x plus 5. That is equals to -2 of 2x plus 5, right? Because already when we multiply this would just give us -2 square root 2x plus 5. And so 2x plus 5, the square root 2x plus 5 multiplied by the square root 2x plus 5 would just give us the same thing, which would be 2x. Basically, the square root would be cancelled out, right? So it wouldn't give us 2x plus 5, sorry. And then after that, when we multiply by there, then it would just give us -3, and then we'd be left with square root 2x plus 5, like that. And then from here, it's 2x plus 5 minus 3. So we can actually write this as 2x plus 2, and then plus 2 of the square root 2x plus 5 is equals to 0. Okay, in this case, you could have done it as previously, but in this case, let's try and do it a bit differently. So here, you've already gotten that it's 2x plus 2, which is -3, and then you have on this side a square root on its own, right? So let's try and get rid of the square root. So if you have to get rid of the square root in this case, then we would have square rooted on both sides, square and square. But then this square here just means it's 2x plus 2 of 2x plus 2, right? And here would be 4 of 2x plus 5, right? We've gotten rid of the square root, and then -2 becomes 4. And so then from here, the only thing we need to do, then we multiply that to there, and that to there, that to there, that to there. So that would be 4x squared. This would be 4x plus 4x, that is 8x, right? And plus 4. and then on this side then it's 8x plus 20, right? And then from here we can see we have 8x and 8x on both sides, positive 8x. So if we take that one on that side, it just cancels each other out. So we'll be left with 4x squared, right? And we take them 4 onto the other side, or we can just take 20 onto this side. So if we take 20 onto this side, then it's minus 16. And this is a difference of two squares, right? If it's a difference of two squares, then it's 2x minus 4 and 2x plus 4, right? And that's equals to 0. And therefore we have 2x minus 4, that's equals to 0, or 2x plus 4, that's equals to 0. And then in this case you get that it is supposed to be minus 2, and in this case you get that it's supposed to be 2. But we've already established which one is the solution and which one is not the solution. So x is equals to 2 can't be the solution, and x minus 2 is the solution. So basically that's how you could have done these particular questions, and I hope that this makes sense, and I hope that everything that has been explained in this video is helpful. Other than that, the next question, the next half of this question 1 will come quite soon. Other than that, thank you for watching, and I'll see you next time.